So we can generate a semi-random or quasi-random texture using different approaches. Let's say we have a lattice defined at integer coordinates. Okay, so at every integer coordinate, and this can be in 3D, okay, x, let's say, y, and it could also go along the other dimension, okay? You can call z. Okay, so we can have a lattice, and at every vertex on this lattice, we can use some random vectors. Okay, so for example here, we can have a vector like this. Then here we can have a vector like that. We can have this vector, and we can have this vector for every vertex on this lattice. And these vertices are at integer coordinates. So for example, this is maybe x0, y0, z0. This is x1, y0, z0, and so on. Okay, so at every lattice point is in integer coordinates. Now, one approach would be to randomly generate for every point on the lattice a vector. Okay, so we have a vector for every point on the lattice, and for any intermediate point, let's show it with this color. For every intermediate point, we compute a weighted average, a noise value, using these vectors stored at lattice points. Okay. Now, Perlin noise is a method like this, but the benefit of this method is you don't need to store these vectors at every lattice points. You can compute them in a random manner, and as long as you have a sufficiently large number of vectors, okay, Perlin actually proposes to use 16 vectors, and you distribute these 16 vectors semi-randomly on every lattice point, you can get a very nice looking noise that appears both smooth and random.